Hi everybody, Andrew Milner here. I'm a quality leader in the additive manufacturing sector and also a qualified lead auditor for the Aerospace Series Standards in ISO 9001. This is the first episode of Assurance with Andrew, and in today's episode I'm going to be talking all about international quality standards, the role of big data, and what the future may hold in development of future industry standards and specifications. And I'd also like to first of all start with a question. Is ISO 9001 still relevant in today's manufacturing sector? So for many years, ISO 9001 has been the most popular standard worldwide. It's been adopted by companies in many different industries, and in a lot of cases it's actually a prerequisite to get onto tender lists and to do business with certain primes. However, the standard itself can be quite generic in places, as it's written to cover many different types of industry and every business from sole traders up to international conglomerates. With this almost one-size-fits-all approach, sometimes it can be less prescriptive than it needs to be, and I would question whether it actually meets the quality requirements and needs of every industry. So what is an industry-specific standard, you may ask? So a couple of examples that you might have heard of. Probably I'll start with some of the more common ones. So there's AS9100 series, which is specific to aerospace, space and defense. There's TS16949, which is the international standard for automotive supply chain. And there's also ISO 13485, which is for medical device manufacturers. So those are just a couple of examples. There are many more, touching on everything from food safety and food manufacturing through to railway supply chain. So the way I describe these standards is they are kind of like ISO 9001 on steroids. A lot of the standards are written from the basic principles of 9001, but they incorporate the specific requirements that are important to that particular industry and meet the needs of that industry, as well as speaking the same language. For example, in AS9100, the standard introduces a number of additional requirements that are specific to the aerospace industry. Things such as first article inspection, also known as production process verification, the need to validate and control special processes. Also introduces requirements around product safety, prevention of counterfeit parts, and training of personnel in product safety. So this sounds great, right? You're working to a set of internationally recognized quality standards that meet the needs of your industry. So there are some issues and some challenges that need to be overcome. First of all is the additional requirements may be quite onerous for some companies. So particularly medical and aerospace start to introduce more record-keeping requirements. And if you're applying the standard and becoming certified to the standard for one customer or one potential customer, it could be quite burdensome in terms of time and resource, in terms of the upkeep that's required. Secondly, certification body resources. So with them being more specialist standards, the competency requirements for an accredited certification body are a lot higher. That means there's likely to be less auditors available worldwide, and there'll be less certification bodies that are involved in that scope of work. As a result, if you're in a more remote location, or you're away from a major city or metropolitan area, you may find that finding audit dates that work for you and being able to work with a certification body that is sufficiently resourced for this work may be a challenge depending on where you are. And then even after becoming certified, you may also find that the customers you're dealing with in industries like medical, aerospace, automotive, in addition to the standard, they may also have their own supplier quality requirements that they flow down through the supply chain. And you may end up having to front customer audits as well as surveillance audits from your certification body. So industry-specific standards are not without their challenges. On the whole, I think they're a really good thing, and it's something that you should definitely consider if you want to demonstrate leadership in the market and acquire potential new customers and new business. However, there are, like I said, some challenges, and one I'd like to focus on in particular is the variance in customer requirements that are flowed down on top of this. And we're going to use the example of something which is known as harmonized standards and supplemental standards. And the example that I'd like to talk about specifically is the new standard AS13100, which has been developed by the AESQ. That stands for Aerospace Engine Supplier Quality Group. If you have AS9100, of course, that is more specific, more targeted to aerospace, space and defence. However, there are many, many different components that go on an aircraft, and the level of expectation from the customer and the expectation from the regulator will probably vary quite broadly depending on what the part is. For example, if you're manufacturing engine components, you're more likely to be subjected to much more stringent quality standards and regulatory surveillance than, say, compared to an organisation which is manufacturing cabin fittings and dinner trolleys. And this variation, of course, means that the players further up the supply chain, the OEMs, are likely to perceive that as more of a risk and build in more of their own quality requirements that they flow down through the supply chain. So what this means in practical terms is you may have AS9100, but if you're manufacturing a critical component or a critical part that goes in a highly regulated, high-risk application within the aircraft, you may find that you're also having to comply with other customer standards and front customer audits. With that, again, comes a cost, because there's a cost associated with compliance, whether that be record keeping, having to use certain forms and documents for one customer and then completely different forms and documents for another customer. That variation, again, can be very difficult to manage. So the intent of AS13100 was really to serve as a supplementary standard to AS9100. So we first of all have the basic framework, which is ISO9001. We then have AS9100, which, using the analogy earlier, is like ISO9001 on steroids. So it's basically the bones of 9001, but with those additional requirements and the terminology that is applied broadly in the aerospace industry. And then a level below that, we would then have AS13100, which is essentially a supplemental standard that works with AS9100, but it addresses the quality requirements and considerations that are specific to the aircraft engine business. So it will follow the same clause structure, but it will have standardization of things like forms, templates, a common approach to product development, set criteria and ways of doing things like problem solving and defect resolution, and be written in a way and a terminology which is compatible with the aero engines sector. And really the aim of this was the consortium, the group that got together and developed this standard. They are a group of aerospace primes and tier ones supplying into the aero engines market segment. And what they were aiming to do was standardize a lot of their terms and conditions and supplier quality requirements that they flow down to their sub-tier suppliers. So rather than having, say, 3 engine manufacturers with 10 sub-tiers with many, many more sub-tiers beyond that, all flowing down very different requirements that are specific to one aircraft engine manufacturer, it's really trying to harmonise that. So the costs of compliance are less, it's less burden on the sub-tier suppliers, and with that comes a lot of benefits. So for example, it frees up time and resources and money to focus on innovation. So rather than having to task manufacturing engineers and quality engineers with understanding all these different requirements and using many different forms, templates, approaches, and so on, their time can now be freed up to work on other things like continual improvement and working cost out of the process. Also, with the standards being more clear-cut right from the beginning, it probably incentivizes other companies that aren't currently involved in that market segment to give it a go, because they know pretty early on what they're getting themselves in for. They're not having to deal with different customers that have different supply quality requirements that vary wildly. There's a known industry standard, AS13100, which would give them an idea what's expected. And of course, more competition in the market, ultimately it's going to benefit the people at the top, who are, of course, the main developers of the standard. So earlier in the article, I mentioned about certification body resourcing as a potential barrier to execution of industry-specific standards. So that's one element. Also, I mentioned in the article that actually writing a technical standard, probably more on the product certification side of things, can be quite a time-consuming exercise. The committees and groups that write these product-specific standards, they're usually made up of a number of different subject matter experts. Many of them may have other roles in industry, and they may be doing it on a voluntary basis. And of course, when you have such a large group of technical experts and they're discussing stuff that's very highly technical in nature, it can take a long time to get consensus of opinion and ultimately publish the standard. So how do I think in the future we could get through these problems and leverage big data to fix that? So before we go any further, I think it's worth just explaining a couple of things and providing a bit more clarity in terms of the definitions. So first of all, if we go back to basic principles, what actually is a standard? So a standard is a common set of rules, principles, and best practices that have been agreed by an industry and experts in the subject matter. Really, what a standard does is it gives the market, it gives the consumer an expectation. They know that if they purchase a product that's certified to that standard, it will comply with a minimum set of requirements. Similarly, if it's a management system standard, so if it was, say, ISO9001 or AS9100, you know that if you're doing business with that supplier, that they are going to be following certain frameworks and certain methods that are recognised across industry and globally too. And that should then make it easier to do business with them. So second definition would be big data. So big data is a term that gets bounced around a lot these days. And the most concise definition I would say is it's really a computational analysis of extremely large data sets to reveal patterns, trends, and associations, usually to do with human behavior. So processing of big data relies quite heavily on software, but as the software gets more advanced and also more accessible, I think it has two potentially really good applications in the world of quality and standards. So number one, first of all, quality management system certification. So I'm going to rewind things a little bit here and go back to the very general quality standards that apply to many different companies. So at the moment, when you have an audit, there is a audit duration, which is usually based on risk and the size of your business and the complexity of the processes. And then each year there is a surveillance visit where an audit will be carried out in accordance with that duration, so maybe 2 days, 3 days, and there's a certain framework that has to be covered over the 3-year cycle. We as auditors have quite a lot to cover in a short space of time. The way that I think big data could really assist with this and with future revisions of QMS standards like ISO 9001 is that it could do a keyword and customer sentiment search of a lot of publicly available databases and data sources. So this could be online reviews, it could be news coverage, social media posts, and so on. So in a really straightforward example, if you were manufacturing washing machines and the washing machines were not very good, you may have a lot of very angry customers posting tweets, writing terrible reviews on Google and other websites, and also just the general sentiment language that's being used on social media and potentially press coverage as well could start to reveal a bit of a trend. It may be with a certain product, it may be with a certain region, it could be many other things. Anyway, with all these data points, the certification body could then start to build a trend of the organisation that they certify. Where are the pain points? Where are the areas of the business that are really having a negative effect and creating a negative perception outside of the company? That would then allow for a more tailored audit approach where they focus on the areas that are higher risk. So rather than spending half a day looking at something which is actually quite mature and very low risk in the context of that business, they're actually spending the time focusing on the departments and the parts of the business that could be attributed to some of this customer dissatisfaction. It could also work for the standards writing bodies as well. So for future revisions of the standard, this data collected from a variety of sources could reveal trends relating to weaknesses across the industry. Maybe a particular group of companies really struggle with complaint management, for example, or maybe the packaging of products leaves a lot to be desired. And over time, this trend could be built up and it could be used to tighten up different areas of the standard and perhaps make it a bit more prescriptive where companies seem to be struggling. So, second application of big data is with product certification. So, product certification, as mentioned earlier when I was going through the definition of what a standard actually is it sets a standard is something that sets an expectation for the market, right? You know that if you buy a widget, that it can be put into a specific application, it can hold X amount of pressure, for example. So a lot of these expectations are derived from standards, and there are thousands, if not hundreds and thousands of these worldwide. So it could be anything from aircraft components, parts to go in nuclear power stations, parts to go in deep sea or oil and gas. And a lot of these standards have been around for a very long time. I know during my time in the aerospace industry, quite often I'll be looking at standards that were first published in the 1950s. And with all that many decades of experience, what we find is that there's a very established trend of these standards working. It's been through many revisions, it's been refined and improved over time, and the industry, rightly so, has a lot of confidence in them, which is fantastic. However, sometimes these standards haven't really kept up with trends in manufacturing and new manufacturing techniques that are becoming more mainstream. So a good example of this is additive manufacturing. So additive manufacturing has come along a lot in the last 20 years. And there are organisations now that are capable of making high integrity, thin wall pressure vessels that can probably meet, if not exceed, the requirements of traditional methods like casting, for example. And there's a lot of other benefits as well. So potentially it could be less cost, less weight, and it could be a really attractive proposition for any prospective customer. However, what I'm seeing as a quality professional is sometimes the barrier to implementation is there's just simply not a standard that exists. And the standards that are under development can sometimes take time, and there is potentially really good technology out there that's not being utilised the way it could be. So how does this link back to big data? So the way I see big data working to overcome this challenge is big data can collect data points from a variety of sources. So this could be during the qualification process of a additive 3D printed part. It could be through a very complex inspection process like CT scanning, load testing, pressure testing, environmental testing. Typically these are very stressful tests, quite often pushing the product to the point of destruction, and it's big expenditure, typically performed by one company to validate their own product. However, if this information was made more widely available, big data software could pick up these data points from across the industry and start to build up a trend of failure points. So over time, all of this data and all of the variables going into each product can be used to build up a trend over time of how the design of the product can influence the outcomes of the test. And then with the use of predictive analytics and some expert input, it can be used to start to formulate rules and methods that would typically take a lot longer through every company doing those tests in isolation and reporting the data back through traditional forums and mechanisms. The benefits would be that new standards would take a lot less time to be published, and there'd be a lot more data in support of new manufacturing technologies and how they can be applied to industries that have relied on more traditional manufacturing techniques, as essentially big data and predictive analytics would accelerate that process. So the opportunity here is for companies that are using destructive test methods and very expensive test methods to validate their products. Perhaps this could be through load testing, environmental testing, any other kind of destructive testing, or potentially could just be really detailed inspection that's quite expensive, like CT scanning. This could be an opportunity to build up a real large set of data, which then could be run through some of these analytical software packages and used to put forward a case for this technology, whatever technology they're using could be 3D printing, for example. It could then be used to put forward a case for standards and design codes that are supported by this data. And then how this would work in the interest of the company is if no such standard exists, and if they're able to be at the forefront of development of that standard, it potentially could open many doors for them. If there's a certain industry that's interested in using, for example, 3D printing, if the standard can come to publication a lot quicker, it can then be an avenue to actually get into that particular line of work for that industry, because as well as demonstrating your technology, the fact that it's proven and it's capable, you can also demonstrate that there's industry consensus and expert backing independently of your company that supports use of that particular product. So that was just a short example of how more harmonized standards for quality management systems can benefit an entire market segment, with the example of the AESQ's work with the AS13100 standard. And we also touched on how technology such as big data and predictive analytics could help shape the future of certification auditing and also the development of product-specific certification standards. So back to my original question, do I still think ISO 9001 is relevant in today's manufacturing world? Yes, absolutely. I think it's still the gold standard in terms of a baseline and a starting point, really. So fundamentally, it works. It's proven. It still remains one of the most popular standards worldwide. However, I do think that in many more niche industries, such as medical, aerospace, and automotive, that 9001 may not be prescriptive enough in some cases. And by implementing an industry-specific standard like AS9100 or ISO 13485, you can demonstrate leadership in your market, that you're serious about getting more work with customers dealing in those sectors. And also there's simply the benefits to your quality system as well from working to a more stringent set of requirements. Now, there's quite often a misconception that it's only for big players in the industry and that it's only for big corporations, big primes, and no, that's not necessarily the case. I've worked with companies with less than 4 people that have implemented some of these more specialist standards, and they're really reaping the benefits of that now and getting contracts with some big primes. All it takes is a bit more focus and dedication, willing to provide a bit more resource in terms of managing it and getting certified, but potentially could open up a lot of opportunities for you. And you'll find that there's a lot better interoperability with supply chain partners further up the chain. So secondly, the next step beyond a industry-specific standard could be to work with the rest of the market on a harmonized standard. So using the example of AS13100, if there is a small number of customers that are buying from a much broader supply chain, but they're ultimately all after the same thing and have to abide by the same expectations from the end user and the regulator, there could be some advantages to actually more collaboration on these supplementary standards that would slot into existing quality management system standards, but provide a bit more clarity around the context of the needs of that specific market segment. And then the final step beyond this really goes down to the more product-specific level. So if you're performing extensive validation testing of products, perhaps through very expensive and specialist inspection methods or destructive testing, if that data can be captured and used to build a trend and correlated with your design decisions, for example, if that information can then be taken to the wider community and you can partner with standards bodies and actually get some of these principles and best practices agreed and written into international standards. And if you're the company that's leading that and driving that, potentially you could open doors to a lot of new customers, as you will not just be able to go and say that you have a quality product, you also have a recognized industry standard which has been certified by experts and bought off by experts. So finally, thank you for watching this video and reading my article. Really look forward to hearing what you have to say. Let me know in the comments or drop me a message on LinkedIn. And don't forget to follow the hashtag #AssuranceWithAndrew. Take care.